Hello friends, today we will be doing some problems based on projectile motion, and the start of this video will have that page having those problems written on it. Now the point is that the very first problem is that you have an airplane. This airplane is moving horizontally with the speed of 200 meters per second, and this airplane is at a height of 2 kilometers with respect to the ground, and we have an anti-aircraft gun, and we have to shoot the bullet from this gun, making some angle theta with the vertical, and we shoot the bullet with a muzzle speed of 600 meters per second. So the question here is that what should be the angle of projection with respect to the vertical, so that the bullet shot by this anti-aircraft gun hits the airplane, and this airplane is moving with the speed 200 meters per second. So in order to solve this problem, I suppose that V is the speed of this aircraft, and this speed is 200 meters per second. Okay, this aircraft is at a height of 2 kilometers, that is 2,000 meters. And if the bullet has to hit the aircraft, the equations of motion involving time must be same. The equations of motion involving time must be same. So I can write down the speed of aircraft is the distance that it will cover horizontally. Suppose that is x, divide by t. So this implies the distance it covers for the time t is vt. So this x must be 200t. Now, a bullet has to be shot from the ground using an anti-aircraft gun, and it has a muzzle speed. Its initial velocity is 600 meters per second. So I should write down the horizontal component of its velocity. So what will be the horizontal component of its velocity? Certainly that must be u sine theta. Now how much is u? U is 600 sine theta. And the point is that this bullet should cover the equal horizontal distance if it has to hit the aircraft. So the point is that this x for bullet, this x is for the plane and this x is for the bullet, it must be speed. How much is speed? That's 600 sine theta, And how much is time? Time is t. This xp must be same as that of xb. What will happen then? I will get 200 t is equal to 600 sine theta t. This t and t is removed. Sine theta will be 200 by 600. So sine theta will be 1 by 3. So theta will be sine inverse of 1 by 3. So this must be the angle of projection with respect to the vertical, so that the bullet that is hit with this speed will hit the aircraft. Now, the second important question in the same problem is that what should be the height chosen by the aircraft so that the bullets that have been shot from the ground does not hit this airplane. In order to do that, the solution should be quite simple. The solution should be, all I have to do is to calculate the maximum height of this bullet that it can achieve. So, what is the expression for maximum height? The expression for maximum height is h is u square sine square theta by by 2g. But theta is here vertical. So h must be here u square sine square 90 minus theta divided by 2g. So h must be u square cos square theta divided by g. So what we have to do is to calculate this expression. On calculating this expression, we will be able to calculate the maximum height. Once we calculate the maximum height, then the height above that height will be the safe height for the aeroplane. Now we can draw the values here. U is 600 into 600. Cos square theta is 1 minus sine square theta divided by 2g. So h will be equal to, this is, okay, 600 into 600 into 1 minus sine square theta. We have already got that sine theta is 1 by 3. So what is sine square theta? That is 1 by 9. So what is 1 minus sine square theta? That is 1 minus 1 by 9 divided by 2g. So h will be equal to 600 into 600 into 8 divided by 2 into 10, taking the value of g equal to 10 into 9. So this is 3 3s are, this is 3 2s are, this is 3 1s are, this is 3 2s are, this is 2 1s are, 2 4s are, this 0 and 0 will go. So h will come out to be 16,000 meters. So the maximum height is 16 kilometers. What does it mean? It means the aircraft should fly above 16 kilometers with respect to the ground. On that height, this anti-aircraft gun, having a muzzle speed 600 meters per second, cannot hit this airplane. So this is the solution of the first problem. Now let's go with the next problem. The next problem is very interesting, and it involves a very good concept of physics as well. The problem is that someone has to shoot, say anything, maybe he has to shoot a ball. Let's use a ball. We don't want bullets to be shot. So, at some height, there's a cat. There's a cat here. And we have to shoot this ball to the cat. The ball is shot from the ground, aiming the gun towards the cat. And at the same time, the cat makes a jump. It falls. Suppose it falls. It falls a height equal to, say, y1. The gun has been aimed towards the cat at the time of shot, making an angle theta. Now the question is that if the gun is aimed at the cat and at the same time the ball has been shot towards the cat and at the same time the cat falls. Now the question is whether this ball will hit the cat or not. This is the problem. The question is whether the ball that has been shot, will it hit the cat or not? I think the question is clear now. The time the ball has been shot from here is same as the time the cat is jumping downwards. And the ball has been shot. The question is whether this ball will hit the cat, a falling cat. Now, we would like to solve this problem. The first thing I would like to calculate is for that time, for the time the ball has been shot from the ground, how much vertical distance this cat will have covered. So, what will be that vertical distance, vertical displacement? What will be vertical displacement of cat during that fall? So that will be y1 I have named that is 1/2 of gt square because it's a free fall. The cat must have fell down for the time the bullet will remain in air. That height will be 1/2 of gt square, where all of you know g is acceleration due to gravity and t is the time. Now, the next thing that I would like to calculate is, see, the gun is aimed towards the cat, but this is not the actual trajectory of the ball, because the ball is also moving under the influence of acceleration due to gravity of Earth. So what's going to happen in this case is I have to calculate that how much height the bullet will lose with respect to its original target. So for that, what should I do? First of all, I should calculate the vertical displacement of this ball. Okay, what will be the vertical displacement? Vertical displacement of ball. Come on, what will be that? That will be, I will call that y, okay? That will be u sine theta t minus 1/2 of gt square. This is the vertical displacement of this ball. It will have taken a height equal to y is equal to u sine theta t minus 1/2 of gt square. Now this y, what is this y? This y is this much of height. This is y. If I take this whole height where the cat was, if I take this equal to h, okay. If I take this equal to h, instead of this y, can I write h minus y1? H minus y1 will be equal to u sine theta t minus 1/2 of gt square. Alright? Now you see, this u sine theta is the vertical component of initial velocity of the ball. What is its horizontal component? The horizontal component of this will be what? That will be u cos theta. So what will be the horizontal displacement? That will be x, suppose, is equal to u cos theta t. So what will be t for that equation? That will be x by u cos theta. Alright, fine, nothing wrong with that. So in this equation, for this time t, I can use x by u cos theta because I want to see what is y1 coming here. If I get y1 is 1/2 of gt square, that will verify the problem. The answer to this problem will be yes, the ball is going to shoot this cat. The ball is going to hit this cat. Alright, so what's going to happen? So h minus y1 will be u sine theta. Instead of t, what am I going to write? I'm going to write x by u cos theta minus 1/2 of gt square. So you can see this u and u will cancel. So h minus y1 will be x tan theta. X tan theta minus 1/2 of gt square. Nothing wrong with that. Now tell me, what is this h? I think this h, come on, what is this h? This h is the total height with respect to the ground when the cat was at rest. And what is this? This is the horizontal displacement. This is x. So what about tan theta? I can write tan theta is equal to perpendicular by base, that is h by x. What does that mean? That means this h is equal to x tan theta. I can use this h in this equation, but I'll get x tan theta minus y1 is equal to x tan theta minus 1/2 of gt square. This x tan theta and x tan theta will be removed from this equation. This minus and minus will be removed, and y1 will come 1/2 of gt square. So you must have seen that the height that was lost by the cat is equal to the height that has been lost by the ball when it was shot in air. That means this ball is going to hit this cat, provided you aim your gun towards the cat at the time of fall. This must be a simultaneous action between a ball shot from the ground and the jumping of the cat. and the fall of the cat. The fall will be a proper word in this situation. So I think